Hi Will, hi Dr. King. Hope you guys are doing good. In this video, I am going to be going over group BB SKAM's assembly and talking about all of the mates that we put in this assembly. This is our entire assembly. We split it up into one subassembly and then we put that subassembly into this assembly. So this right here is the claw portion of our project, and we made this as the subassembly. So what I'll do is I'll go into that subassembly first and talk about all the mates in this subassembly and then go back to the main assembly. So what I'll do is I will go through each of the mates and I will basically suppress them as if to basically make it seem like they were never there. And I will move those components away that were a part of those mates, and then I will unsuppress to show how the mates work together. Okay, so the first mate is a concentric mate. I'm going to suppress this. So now, if I move this portion out, it is able to move out. If I go back and click unsuppress, this portion moves back onto the base so that it is concentric with the base. So the hole in the base, which is at the bottom right here, becomes concentric with this sprocket right here. The next mate I will suppress now. Oops. Okay, so this is a coincident mate between the sprocket, the left sprocket, and the base. So let me go ahead and suppress this. And now if I move this, everything becomes messed up because the sprocket is able to move away from the base where it was supposed to be on top. So if I unsuppress, that basically puts the sprocket on top of the base with the coincident mate right here. So now this sprocket is on top of the base with the coincident mate. The next mate is the same mate as the first mate that I showed you. It's a concentric mate. If I suppress it, move this out, we can see that this hole and this part are not aligned right now. And then if I go back down and unsuppress, the sprocket comes back onto the base and the middle of the sprocket is concentric with the hole in the sprocket. Now this is a coincident mate, and this coincident mate is between this gear insert and the sprocket. So let me suppress that. So I just removed that coincident mate. So now we see that everything gets moved out of the way once I try to move that. So I'm going to unsuppress. And then now the inside face of this gear insert is coincident with the inside of the sprocket itself, so that they stay connected together instead of moving around like I just showed without the mate itself. This is the same type. This concentric mate is the same mate that I showed beforehand with the other sprocket. This is the same concentric mate that I showed with the other sprocket. This is the same coincident mate that I showed with the first sprocket. So there's a lot of repetition because, as you guys can see, there is a symmetry to the claw because it's divided down the middle. So a lot of these mates are going to be the same but just repeated on the other side. So to not be redundant, I will talk about one side and just make sure that I mention that the other side is the same as the first side. So this was the mate that I just talked about. This is the concentric mate that I was talking about earlier with the first sprocket. Now here we have a concentric mate. Now I'll suppress this. So it's between the base piece and this rod. So as you guys can see, if I move it, it moves outside of that hole. And then I unsuppress, and the two circles become aligned. So that concentric mate allows the prong and the base upright part to become aligned. Next mate is the coincident mate between the prong itself and the base. So if you guys can see, I'm able to slide this over and under the base because there's no coincident mate there. If I go back down and click unsuppress, now it's in place and now it's not going to move if I try to move it up and down. Let me see where I'm going next. So this concentric mate is just similar to the concentric mate that I just showed previously 2 mates ago. This mate and this mate right here are basically the same, but just on opposite sides. This mate is the same as what I just talked about. This is the same type of coincident mate. I will re-show this right now that I just talked about. So if I go ahead, I made the same mistake again. If I suppress this, you guys can see that I'm able to move this up and down through the base itself, and it's messing up the entire assembly. If I unsuppress, now we have that coincident mate, and this becomes locked in position with the base. And now we can talk about another concentric mate, which is on the bottom side right here. So it's the same idea that I've been talking about. If I remove this prong, you guys can see that it's basically getting moved all over the place. And then I unsuppress it, and the prong becomes aligned with the base. There we go. Okay. Let's see what we have next. So we're on the bottom side right here. So these two mates are the exact same mates, but they're just on opposite sides of the base. It's just what I just talked about with the concentric mates to align the circles of the prong and the hole in the base. Now this is a coincident mate between the bottom face of the plate and the top circular edge of this pin plate. So I will suppress this. So now you guys can see that I'm able to move this around because that edge is no longer coincident with the face, and it messes up the subassembly. I will unsuppress. Now it's fixed in position, and now it won't be able to move outside of the way I was basically moving it earlier. These two mates are the exact same mates, but just on opposite sides, just like I talked about. There's a lot of mates, I know, I'm trying to be fast. We have this concentric mate, same idea as I've been talking about. If I suppress, move this guy around, so we can see that it's moving all over the place. And then I go back down, I click unsuppress. Then the circles become aligned with the base, and now it's not going to move around. Now this is a coincident mate. Let me suppress it. Once I suppress, you can see that this is able to, the prong itself is able to move through the base because there's no coincident mate. Now if I unsuppress, the prong becomes coincident with the bottom face. The top face of the prong becomes coincident with the bottom face of the base, and now it won't be able to move like it was moving just before that. This concentric mate is just what I talked about on this first side, but it's just on the other side, so it's the same idea. This is the same coincident mate that I just talked about on this first side. It's the same thing on the other side. Now we have two parallel mates, one on each side of this subassembly. So one is on this side, one is on this side. I'll highlight it right here. This is the first side. This is the second side. So let me suppress the first side. And now if I am to move this, you guys can see that the top prong is moving, but the bottom prong is not moving with it. So this is why a parallel mate was needed to basically join and keep the top and bottom prongs aligned when the gear was working. So let me unsuppress, and now if I move it, we can see that the top and bottom prongs are parallel and moving together, which is exactly what we wanted, so that the claw mechanism works. The same type of mate is on the other side. It's the exact same idea. Almost there. Okay, so now we have a coincident mate right here between, let's see, between this long thin plate and the pin plate itself. Let me suppress that. If I remove that, you guys can see that this is able to move in and out, and it's not joined with the pin plate. So now I need to go in, unsuppress, and now you can see that this face and the back face of the pin plate are joined together, so that this entire assembly is joined. The claw is joined to this long pole. Where were we? Okay, so we just talked about that coincident mate. Now we'll talk about some concentric mates. So this concentric mate right here is basically to line up the two holes in the pin plate and the plate so that we could put screws through them and join them together once we print out our parts. So if I suppress, this is free to rotate around, which is not what we want because we want to be able to put the screws in. So this is why this mate was needed. And then we unsuppress, and we have the holes lined up. Let's see here. Let me go back. Okay, so we just talked about that concentric mate. This concentric mate is the same idea with the prongs and the claws. Let me quickly suppress it. If I just move this, you can see that the hole is not aligned with the hole in the pincher. Let me unsuppress, and now it's aligned. So now if I move, it moves with it. Every time I do this, I keep having to scroll down. Let me find out exactly where I am. Okay, so right here, this next mate is a coincident mate between the prong and the pincher. So let me suppress. If I suppress it, it's not able to be shown, but basically because everything else is joined, or mated I should say. But basically what would happen is without this mate, this pincher would be free to move up and down technically. And we don't want that. We want it to be able to move along with the prong. So that is why this mate was needed. And let me unsuppress. Okay. Now we have the same concentric mates on the top in the back right there, and then on the bottom. It's the same idea that I've been talking about this entire time. We have another coincident mate. It's the same idea on the bottom side between the prong and the pincher. Let me just quickly suppress it. If I were to move this up and down, or this prong up and down, you can see that it's able to move through the pincher, which is not what we want. So if it's out over there, that's not good. So we added this coincident mate so that the prong would stay connected just like that to the pincher, and it would move with the pincher. Let's see here. Almost there to the gear mate. Yeah, so now we're at the gear mate. The gear mate is very self-explanatory. We have these two sprockets and we needed them to work in a gear-like fashion. So that's why we added this mate. So let me suppress it. So without the mate, one sprocket is rotating completely without having any effect on the other sprocket, which is not what we want, because we want to be able to see what's going on physically in this assembly. So this is why this mate was needed, so that we could check the physical attributes of these two sprockets working together. So I unsuppress, and now if I move back and forth, this works out.